So here's another great example where you're tempted to think that this is also a case where either would apply. Does it actually apply? Let's see. Statement 1, some kites are horses. Two intersecting circles. This is kites, kites. This is horses. Statement 2, all horses are dogs. So you put horses inside dogs, right? Now, I want to apply my universal rules and see if I can get any conclusion to be always true. All horses are dogs, some dogs are horses. All A are B, some B are A. So conclusion 2 is always true for me. Conclusion 2 is always true. Now the conclusion 1 is saying all dogs are horses. So some students get confused if maybe the answer should be E. Guys, kites has not been mentioned at all. It's fine. Nobody cares about kites, so we also don't care about kites. The whole question is revolving around the relationship between dogs and horses. So one way of combining these two would be to draw a diagram like this. Okay, so this is kites, this is horses, and this is dogs. Alright, one way would be this, another way would be this, where this is kites and this circle is dogs, comma, horses. Both are right, nothing wrong, either of them. This is just the special case diagram, this is the general case diagram. Now, as per this diagram, the conclusion 1, all dogs are horses, is wrong, right? It's only some. Horses is within dog circle. So conclusion 1, I found a diagram that can disprove it. When conclusion 1 is false, is conclusion 2 true? Some dogs are horses is true. So conclusion 1 is false, conclusion 2 is true. Most students stop here. They draw this diagram, they see that there is a false true relationship and they assume that the answer is E, either conclusion 1 or conclusion 2 is true. However, this is the wrong answer. This is not the right answer because we already applied the universal rule to get conclusion 2. So conclusion 2 has to be true all the time. There is no either business going on with 2. It's always true. There's just nothing else to be decided here. 1, however, we found a diagram to disprove it. If you look at this diagram, conclusion 1 is all dogs are horses. As per this diagram, 1 turns out to be true. But 2 is also true. 2 is not false as per this diagram. So 2 is still true. Some dogs are horses. It turns out that all dogs are horses in this diagram, but some is a subset of all. So when you can say all, you can also say some. So 2 is still true. 1 has turned from false to true. So 1 actually is wrong. 1 does not follow because I was able to draw a diagram that disproved 1. So A is wrong. C is wrong because I know that 2 is always true. Both is not right. Either is also not right. The answer is B. Conclusion 2 is true.